So in a couple of previous videos, we pulled this Sprinter 1L card out of this Radio Shack Model 1. Completely stripped the card down to the blank PCB, and then sent a bunch of photos, etc. off to a gentleman named Pascal in France, who spun what is nearly a clone of the board. It's got a couple of slight differences. He provided me 3 blank boards. I've got one of the blanks here from his first run. We went ahead in a video and we soldered up one of the boards so we could test it in the Model 1. During this assembly, we actually made a part substitution because I didn't have the right logic device. And the LS device got replaced with essentially a CMOS equivalent. It's right here, 74AC. Can't read the part number on it. At least I think that's the part. I had all the parts digging through my bins. Yeah, 74AC109. I didn't have a 74LS109. I think that'll work okay in there, but we will find out. Difference between the board is, of course, we built up this resistor network here because I didn't have one that would work. This board's got discrete resistors down here on the board. There's actually 2 on the front and 2 I mounted on the back because the spacing in there really wouldn't mount for regular resistors. But it's time we swap this guy in and see if it works. So I know the last time we powered this Model 1 up, it was in a video. See if we can get this card to come up out of there. It's a little bit tight. There, it popped. And really what we need to do here is just unsolder the 4 wires. Pascal had questioned this pull-up resistor here. I know it's not on his design. It was definitely, I received the board this way. I assume it came from the factory that way. It's just a 1K ohm pull-up. If the board doesn't work, we may add that just to see. Pascal reports he's got these boards working, and I think he spun the final design for it. But anyhow, let's go ahead and remove the 4 wires. Oh, I've got the wrong tip on the soldering pencil. Got a big old blade tip on there. Give this a second to heat up. It should be hot by now. Clean it up. A little bit of fresh solder, and we'll just heat and pull these 4 wires out. The orange one here, and the tiny little red one. And that releases this card. We can kind of compare these cards side by side now. You can see overall they're very close. Like I said, there is a little bit of difference. Up in this section here, you can see there's 2 resistors on the top of the card, and I ended up mounting 2 on the bottom. And even though there's silkscreen in there to get all 4 resistors on the front, they're just so tight you can't really fit the resistors in. This came from the factory with 1 of them on the back side. When I reassembled the card, I elected to put 2 on the back side. Pascal reports the first spin of this card is just a tiny bit larger, and it actually looks like it is just a tiny bit bigger. And he said that tiny bit bigger was enough to keep it from mounting in the case, and he's had to file the side here down. I'm sure we'll have to do the same thing. Not going to really worry about it for now. It's a very close clone, very close. He's done a really good job with it. Anyhow, let's take the newly built one and let's swap it in. Actually, let's transfer the processor over to it while it's loose here. think it'll be a little easier to do. The board floating loose. Maybe. This is a Z80B CPU. Hopefully I didn't bend a pin. It was a little bit tight going in. And we've got 4 wires to mount. Yellow is way over here. I can get that to sit reasonably solid. Blue comes to right here, and there's enough solder on the wire here I can't get it through. Or the wire is a little bit too large a diameter. The hole, I'm not sure which. There's a little bit of a kink in that. Let's see if I can straighten it out. The diameter of the hole the wire goes through looks more than sufficient than it is. Let's see if we can get this to kind of just sit in place so we can tack that in. Having the board slide around here is not helpful. There is blue to blue. Orange comes, of course, to the hole there. Labeled O. And finally, the fine red one. The wires that are on this Model 1 are the original wires that were in the system when I received it. I'm not sure why there's 3 larger gauge and 1 smaller gauge wire. It's just the way it was when I received it. Well, you're going to be really stubborn, aren't you? Never have enough hands. Each time I've soldered these wires and removed them, the insulation's backed up a little bit further. Up the wire, meaning I'm getting a little bit longer length hanging out here, so I'm going to trim these back. I don't think they're long enough to short through to anything, but just make sure, and the others I think look fine. So really the next thing is just to hopefully get him lined up on the socket on the motherboard and plug him in. Wow. Yeah, that board is just a tad bit wider. As he said, that was just enough to keep it from actually mounting down in the case. Well, that really completes the installation of it. I think the next step here will be to put it back together, get a monitor hooked up, and see if we have life. So I will come back when that work's been done. So I'm going to need to hand shoot some video here. Apologies for the roughness of it. We've got my monitor hooked up, same one we tested with last time. We've got the keyboard assembly put back together here. The card is hidden down in there. It's the different color green. It actually just did barely fit in, but it did fit. Maybe these cards had been sized. We had a little bit of communication issues. I don't speak French. Pascal speaks some English, so with translation. But it did fit down in. I'm hopeful when I apply power, this thing will actually wake up and work. But the only way to know is to reach down here and hit the power button and see what we get. Well, It's a really good sign. Let me see if I can tweak the video here a bit and get you a little bit better. I think that's better. Shot at the screen. Of course, you can see me in the lab reflected in the background. Print mem. Looks like a normal Model 1 at boot time, so that's a really good sign. Sorry for the camera wandering around here. It's hard to shoot by hand and type. We've got the sheet here that tells us the out commands for the various speeds. So out 254.0 is the default speed of 1.77 megahertz. So let's jump up here to something faster. So out 254.5 should double the clock speed. So let's see if it's even stable at that. Out to my 5 key. Down here, the 5 key down here isn't working. I have to use the keypad. Comma 5. Oops. 5. Well, we didn't lock up and crash. So let's go for the 5.32 megahertz, and that's out 254.12. Out 254. Oops. 254, comma 12. Again, we didn't hang up. So this is a good sign. So it looks like the CMOS substitution I made was a good one. I expected it to work, and it did. And it looks like, you know, the card works. At least at this point, it seems to. We'll have to actually write a bit of code and test speed. And I'll do that next. I'll get some code written to try to demonstrate speed like we did last time. And we'll poke at it and see how it goes. So I'll be back. So I'm back. Apologies for the crows going crazy outside. Not sure what's up with them. I've written a little program here to test 3 different speed modes. We can see the first half of the program here on the screen. We're going to clear the screen. We're going to print out the mode we're in. We're going to actually set the speed mode, in this case 1.77 megahertz. We're going to go down to a subroutine, clear the screen. Faster mode, clear the screen to fastest mode. And if we list the little subroutine, starting at 1000 here, we just set a floating point variable. We loop 25 times. We add it to itself. We multiply it by something. And we print out on the next line the x and y value. We do the loop and return. We'll see if this will actually run and maybe give us a hint at performance. Glare on the screen is irritating. I know last time it was kind of hard to get. Let's see if I can cover that glare up a bit. Still let you see the screen. That may have helped. It was a little hard to get an indication that the speed was actually running quicker, partly because I know wait states get inserted, but let's go ahead and do this. There's definitely a speed difference to 3.55. And it's the same feel I had before. At the 1.77, 3.55 is definitely faster, and the 5.32 might be a little bit faster again. It's pretty funny. The phone is seeing my reflection of my face in the CRT and is trying to focus on my face. Anyhow, we definitely see a speed increase. So I think we've proven the board works. We haven't actually gone in and looked at the clock rate, etc. And I'm pretty confident at the 5.32 there's wait states being inserted, which is why it doesn't seem to double from the 3.55. Of course, 3.55 doubled would be 7, so it's not a 100% increase to 5.32. But there it is. This Sprinter 1L respin board does seem to work. I believe these will be available for sale. I'm sure they'll show up on eBay. I can't think. The gentleman's name is Ian out of Australia that sells a lot of Radio Shack stuff. I think he's going to be the one that's actually going to be selling it. If you're interested, keep an eye there. And there it is. Just kind of running away. Pretty happy with that. I'm realizing you can see the mess that is the lab. Kind of reflected here in the CRT. Is what it is. There's a lot of stuff in the lab. A lot of shelving. Anyhow, hopefully this wasn't too boring, and we'll talk soon.